Today I just want to take a few minutes and introduce Chapter 6. The name of the chapter is Chemical Names and Formulas, but there's a fancy term called nomenclature that just means the naming of chemical substances. How we name them depends on whether they are ionic or covalent. Today we're just going to deal with the ionic compounds. You can follow along on page 5 in the note pack. First thing we need to do is just get some terminology out there. What is an ion? It's a charged atom, which just means it lost or gained electrons. Cations is the fancy book learning term for positive ions. It means they've lost electrons. Anions are negative ions, and that means they have gained electrons. As we turn the page, you'll want to consider just using up one side of your piece of paper, because the way we draw them today with the simple Bohr's models is going to be different than how we use with the symbols that a chemist would normally use, and we'll look at those in class later. So as I look, I need to deal with the sodium atom. First I have to find sodium on the chart and see that it has 11 protons. Now I'm just going to ignore the neutrons for today, and the reason is they really don't play a role in chemical bonding. I do need to pay attention to the electrons because they are extremely important in bonding. So if it's truly an atom and it has 11 protons, that means it also has 11 electrons. And they will fill in the various energy levels, 2 in the first, and that's full or happy or stable, 8 in the second, and 1 in the outermost shell. That's called a valence electron. What we need to look at here is what its charge is. Well, right now the net charge, since it has 11 positives and a total of 11 negatives, its net charge is 0. That makes it an atom. But in order for an atom to be stable or happy, what it needs to do is have a full outer shell. So it's going to try to get rid of or gain electrons so that it has a full outer shell. How can it do that? It has to be in contact with the right chemicals that can either accept or give it some electrons. This one's outer shell or valence shell has 1 electron. Realize if it somehow lost this electron or could give it to something else, it would now look like this, and it would have a full outer shell. Counting up how its charge, if there's 11 protons, which are positive, and 10 electrons, which are negative, its net charge would be a +1. No longer would we call this a sodium atom. It's now a sodium ion, and its symbol would be Na with a plus sign or a +1 sign. You probably see both if you stick with chemistry. Let's look at another atom you're familiar with. Chlorine, which is found over here in the halogens. Chlorine has 17 protons, which also means that it has 17 electrons. Since it has the same number of protons and electrons, it would be called the chlorine atom. When I look at its outer or valence shell, what I can see is it has 7 electrons. It's just 1 away from being a full outer shell. So how could it have a full outer shell? It could either lose those 7, not likely, there's not any substances that will accept 7, or it can be in contact with something that would give it 1. And if it did and it gained 1 electron, if somehow 1 came in, now we'd have 8 in the outer shell. So when I count up its charge, 17 protons, which are positive, 18 electrons, which are negative, the net charge is a -1. No longer is it a chlorine atom. It's now a chlorine ion, or what we'll learn is we'll call that a chloride ion. The symbol for this would be Cl with a minus sign, or often a -1 sign. So as I'm moving down the page and it says what type of bond have we formed, the truth is if we think of sodium and chlorine, if they were in a place where they can be together, sodium wants to get rid of an electron. Chlorine wants to gain an electron. And when they do so, Both of them have a full outer shell. Cross out the word atoms because they're no longer atoms. This is now a sodium with a positive. This is a chlorine with a negative. And as you probably have heard, opposites attract. Sodium chloride is just an ionic compound formed between sodium and the chloride ion. Let's take a look at the next one down. Magnesium, if you find it on your chart, has 12 protons. What does that mean? It also has 12 electrons, 2 in the first shell, 8 in the second shell, and 2 in the third shell. How could this one become happy or stable? Well, it needs to either gain 6 here or it needs to lose 2, and lose 2 is the more likely choice. If it would lose 2, it would now have a full outer shell of 8 in the second energy level. If I count that up, 12 protons, 10 electrons. Protons are positive, electrons are negative. That would have a plus 2 charge. Magnesium has a positive 2 charge. Sometimes you may see it written as a plus plus. It might be better visual for you, but this is pretty common to see it as plus 2. Remember those chlorine ions that we had? The chlorine ion, or the chloride ion, had 17 protons, 2 electrons, 8, and 8 electrons. Normal chlorine atoms have 7 in their outer shell, but let me backtrack. Let's make it an atom first. 2 electrons, 8 electrons, 7 electrons. This is a chlorine atom. And let's put one more of them down here. So when we're looking at what wants to happen, I should have backtracked on that. For now, let's turn it back into the magnesium atom so that we can look at what might cause it to do something like that. The magnesium atom has 2 electrons in its outer shell. If it's in contact or in a container that has chlorine in it, remember chlorine has 17 protons, 2, 8, 7, and we'll put another chlorine over here, 17 protons, 2, 8, 7. What we have is 2 atoms that want to gain an electron to be full, and 1 atom that needs to lose a couple of electrons to be full. So what we'll see is magnesium will give 1 electron to that chlorine and 1 electron to that chlorine. When it does, now it's 8 and 8 here. And when we measure this all up, magnesium has a full valent shell, but it has a plus 2 charge. This chlorine has a full valent shell, but this chlorine has a minus 1 charge. This chlorine also has a full valent shell, and it has a minus 1 charge. So we find that the ratio that ionic compounds are formed with magnesium and chloride is it takes 2 chloride ions bonded to 1 magnesium ion to make the magnesium chloride compound.